Hello, everyone. Thank you for joining this presentation at Remote Fest. The purpose of the talk of this presentation is basically data science for infrastructure, observe, understand, and automate different data science related uh, operations. With me is Sahar. He is the director of engineering at SWVL, currently working from Cairo. But for the brief introduction of him, I let Sahar to introduce himself.
Sure. Hello, everyone. Really awesome to talk to you all, guys. To talk to you all in this venue. I'm Saher. I've been in SWVL for the past 2 years. Currently, I'm an engineering director in SWVL. There are several of us. Mostly, I've been over the past 15 years. I've been in different startups here and there, mostly working in infrastructure. And a little bit more specific, I've also been dabbling into data science and infrastructure. This is a domain that many people have called different things. Most recently, something called ML Ops. But I have a strong passion into how to use data, especially in infrastructure and seeing live products and how we can see data out of them. So I think we're up for a very interesting discussion. So, Sammy, please go ahead.
Yeah, sounds good. Thank you for a brief introduction, sir. In data science, what I've seen in the past few years is that it's the popularity of data sciences is increasing day by day, and a lot of young talent is going into this direction. And the demand in data science, the talent pool is ever increasing. What are the things that have helped to continue to attract great talent towards data?
Yeah. So I always meet young engineers always trying to ask what should they do next, and data science is always a topic that comes up. I think many of us use very highly data-driven products on our day-to-day,
Mhm.
whether we're listening to music, watching news, looking for the next video to watch. So, being data-driven and understanding the products that we're using is something that is motivating lots of people to actually take part into building such products. It's no longer the case that products we're building are these old Web 1.0 or Web
Mhm.
2.0, even where people are reading from a database, doing some CRUD operations. No, data and how dynamically changes our lives is very essential to building these products. So I think this is motivating lots of people to be able to build such products. And without this data science slash software slash ML slash statistics background, it becomes very difficult and kind of corners people into a more traditional version of computer science that people are trying to expand more on. So I'm not
Exactly.
thinking of data science as something that is limited to software engineering. No, it's kind of an expansion of the domain of looking at data and looking at um, what products we build in from a different perspective. We call them data products, so they are regular products, but they are augmented with data to help out people.
Okay, sounds good. Sounds good. But the question remains here that using data science, how can we solve the business problems and the societal problems which we have at a scale?
Yeah. So here are two things. How can we help and
Mhm.
scale? So looking at
Yes.
regular problems, especially if we're starting any new product, classically, even if in our education or different contexts, we start to play with some pet products. These pet products look very small, but once we start tackling actual problems in the ground,
Mhm.
scale and the volume of data that happens is very essential. So, for example, we'll look at lots of commuter data. How can we help our commuters both be safe, save the environment by commuting with buses instead of using individual cars? And there is people are commuting day to day. That's a lot of people. So there
Yes.
is the data and the scale side of it. So looking at user behavior, this actually helps us help people on the ground, whether someone is not moving efficiently, someone is losing money. And in all of our economies these days, saving is really, really important.
Yes.
From there, mixing both this data at scale, especially at real time, and helping people with it, is really essential to solve actual people problems. If we're still assuming these fictional scenarios of building, as I mentioned, classical databases or classical applications, this all lies within the assumptions of whatever product us engineers are building. But once we plug data into it, it
Mhm.
adds this context of, okay, this is what actually is happening to people, without this need to theorize around it. We're just feeding this data with some models or some statistics into something that actually help people out. And this kind of behavior kind of solves actual issues on the ground instead of being completely fictional.
Sounds amazing. I think the key thing here is like basically how, and this would be my next question is how do you detect the patterns about different problems, right? How do we
Yeah.
observe that these are the patterns which we need basically which we identified, and based on that which will we go further.
So looking at academia, and especially with data science and academia, kind of intersect a lot. And from there, pattern recognition is a very old field of statistics. Um, from there are usually two sides to it. There are the batch versions of it and the real time of it. And an advice I give to every engineer, analyst, or data scientist that I talk to is, first and foremost, look at the data that you're receiving as is, without any assumptions. I see lots of people looking at data, looking for a certain signal, instead of removing any assumptions in the first place and
Hmm.
just looking at the data as is. I know lots of people looking at CSVs day to day, either in Excel sheets, in Python, and R, and whatever, and they just try to look for something specific instead of just looking at it without any assumptions at all. Um, without with these assumptions, it's without I'm sorry, without these assumptions, people start to see, okay, this is a pattern I'm starting to see. Just applying some simple statistics. I know lots of people learn
Hmm.
their classical averages and their classical summations from school, looking at more advanced things like standard deviations and medians and more signals and correlations between metrics. Looking at these patterns starts to build a picture. So usually data scientists, when they start looking at data, they try to build this exploratory data analysis. They're trying to explore the data and try to build a story out of it. I know many data scientists that they're very comfortable with building Jupyter notebooks. The whole
Hmm.
point of that Jupyter notebook, or that exploratory data analysis as a notebook, it's kind of, they call it reproducible research, that people can reproduce this research again and again, and that whole notebook tells that story.
Yes.
Um, I find it very strange that when analysts start with an EDA, and the first thing they start writing is code. No, they need to start some text explaining what is the objective they want to do, what is the purpose they want to reach. Then code comes later. So that exploration is like looking at remember those old video games that we all used to play, when you are the single character that has a small light and everything is dark around you, and you start moving around, lighting all over the map. that's what
Hmm.
that's the spirit of data science, and exploring data is really essential to understand what is happening around us. From that analysis, at the end of them, those where models start to result. So after a
Yes.
long exploration analysis, models come at the end instead of at the beginning. And this is another thing that I see, that lots of engineers really excited. They just throw around like linear regressions, trees, neural networks, deep learning. They just throw out all this arsenal of data, of
Yes.
tools, without at least a very simple understanding of how that data looks like. As human beings, we have a better eye of looking at these patterns, and that would direct us in the which direction would we best look at. So yeah, EDAs are essential, exploration and no assumptions, looking at data
So
first.
the a question on top of this is like basically what would be your recommendation to basically understand the data better? You know that people have a lot of know a lot of algorithms and neural networks, etc., etc., but which one is applicable at which problem? Do you have any basically suggestion to give this to any developer or data scientist which is working on a problem?
So so looking at with any data scientist, there is this standard statistical tools that you carry with you. Just looking at correlations, variances in each of the signals, starting to feature engineer and just understand what do these features actually mean. Like for example, in recommendation engines, it's a very common pitfall that you just run collaborative filtering on the data with some users and tags, and that would be it. Although a very simple set intersection would do the same thing. So looking at the data, playing around with it with your own hands, even just looking at the CSV in an Excel sheet for a whole day,
Mhm.
just trying to figure out when we filter this and this signal together, what happens when they're combined together. Then maybe later we'll figure out that these two vectors might need to be multiplied together to get the result. But
Okay.
the human eye is very capable of looking at these patterns better.
Okay, sounds fair. Sounds fair. So, but another question from here would be like basically once we understand the problem, we need something to basically we need some sort of program to basically
Yeah.
have this thing automated. So, do you, what are the tools you are using to basically automate and scale these data related operations at scale and even at Swivel?
So looking at building any data product, we can think of it that it goes through different phases. And the first one is that whole exploration or research phase. Once this is understood, okay, we understand the
Hmm.
parameters of what we want to develop. Obviously, most data scientists now use these whole set of data frame frameworks of either in R or in Python, and they start prototyping these things for testing this out on a small data set of users. Once these
Yes.
apps are built, usually there is this fork in the road that everyone needs to decide. Do you want to build this over a real-time framework or over a batch system? If it's a batch system, like historically, usually these prototypes have a much longer lifespan versus if we are aiming for a fully fledged real-time system. If it's a real-time system, this is where things change drastically, where we need to go to good old software engineering practices, figuring out, okay, how will this data move from one point to the other? How is this whole data
Yes.
pipeline is going to move from user user interactions to actual data sets, then to feature engineering, to feature extraction, to
Hmm.
actually building a model. So this whole process of development, if you think of them as development phases of research, prototyping, and then productionizing an actual system to be actually valid at scale, might need different frameworks. At the beginning, you might be using, for example, things like Julia to do some simple EDAs, then some simple pandas or R and different data
Yeah.
frame technologies to build a batch system, then finally going to the extreme of Rust and Go to build a full model that would be integrated within this whole system. So depends on which phase you are in, and for
Yes.
each has its own system demands and scale requirements.
Okay, an argument a lot of developers made is basically that Python and R are pretty slow when it comes to performance. Like if you compare them with C++ or any other programming language. So how do we basically overcome this if we have a very large data set and we need to basically provide results like very fast results? So how do we overcome this if we have the tools which are available in Python or R?
So most of these systems are very aware that these programming languages are not built for like
Mm,
really huge systems, and most of them like plug into other frameworks that are very native. So, for example, you can plug into a feature extraction library that's concurrently written in C++, but in the end of the day, your glue that plugs in everything together is in Python or in R. But in most of the cases I've seen, even with huge data sets, if you're, for example, using Spark to go through big data, it's all written in Java in the backend, but you're still
yes.
writing Python Spark code at the top, and from there you don't the bottleneck is not the programming language, is the volume of data that you're using, and no single machine would be able to go through this. So usually I don't see that the bottleneck is the language itself. It's more of how we're looking at the data and which stage of that development that you're using. So usually I don't see a major problem with using Python or R for production purposes, as long as you know the context that you're using, and if there is a specific point that is causing a bottleneck, you can just
Mhm.
replace that instead of replacing the whole thing.
Yep, yep. Sounds fair. Sounds fair. Just moving forward with another question, which I think a lot of people ask is how does data science play a role in understanding how production application work?
Yeah. So we see this a lot that production applications are running in some cloud. We don't understand what is actually happening. Then someday the system decides to crash. Things are no longer
Yes.
working. Uh, this is usually a very embarrassing situation if you have no idea what is happening. So having good observability and understanding of the data that your system generates is really important. An example always comes to me of good use for data science and infrastructure. For example, in Google, they kind of detect hardware failures before they actually happen, so they can replace that hardware ahead of time.
Yeah.
The same would happen, for example, if your service is logging a lot of errors, looking at traces of what you're doing, or looking at different metrics of your system. So just like as a data scientist it's really important to feature engineer their products, the same would happen for regular engineers. Having this data mentality is really important. To, okay, which metrics should I expose to my service? How would I
Mhm.
be looking at them in the long run? When something happens, what should be my playbook of what is happening? If I'm hit by a fundamental surprise, like a metric for the first time ever is exploding in our faces, how are we going to behave to it? Patch things up, but what kind of analysis? Even in Swivel, in during incidents, after that, we run, we create explanatory data notebooks, and
Mhm.
that is full of our data and our graphs to understand. Okay, this is the post-mortem that generates it. So
Okay.
I see even for what I would loosely call classical software engineering, having this data science mindset is really important. Looking at your own metrics, understanding how your system behaves, and even would reach to predictions later. There is lots of research into how machine learning can help with production systems, auto recovering or auto healing, and these are really important. If we bridge the gap to classical data science, even in production, there is this whole topic of explainability, that how can my model be easily explainable, that if it made a certain prediction, how would this make sense to actual user? Because in the end of the day, machine learning has become very complex, and there's lots of layers of boosting and other layers of models over each other. Explainability is becoming a really hot topic, because in the end of the day, this recommendation showed up to you because A, B, C, and D. This is a very good user experience. So observability of models or production systems is really important, and data science, the data science mindset plays a really important part into it.
Yep. Okay. So I think we now have a few minutes remaining for this basically chat. So I'll just take a few questions from the audience. Hassan Nadeem just asked that just a beginner question, that how can one jump into data science? How much knowledge of prerequisites is necessary to begin with data science?
Yeah. So I think that's another reason where lots of people are also jumping to data science. It's it's an easy thing to start with.
Mm,
Although it's a very multidisciplinary domain, it needs lots of backgrounds, but each of them do not require from you lots of really hard prerequisites. You can jump into the statistics part really easily. Just don't dive really deep. Jump into
mhm.
another part, and then like taste from each background a little bit, and then dive deeper. So usually there is lots of online courses that provide introduction to analytics. That's usually a very good start. I don't recommend starting with machine learning first or AI courses. Start
Mhm.
with courses that teach you basic analytics and data understanding. From there, you would start looking into introductory courses into classical AI, learning the basics, linear regression optimization. Then after these basic courses, I would heavily advise competing online. There's lots of platforms that help you compete in data science competitions. This is where I think you start gaining most of the experience that you need. Data
Yep.
science is very experience driven,
Yes.
and there's lots of platforms that would help you gain knowledge into those into gaining that experience yourself, which would help you actually start working.
Awesome, awesome. I think we have only a last minute remaining. So this is my personal question to you. Is basically, do you think that from coming from developers background, what kind of learnings you should have to basically kick into the AI or the machine learning track?
So the first thing is to try. The first question would be: is this flavor of development or work is it good for me or not?
Mhm.
And trying here never hurts. And what I've seen is it kind of expands the horizon of engineers in general, that they see as something that is completely new to them. This appetite kind of both break boredom, and at the same time gives you understanding. Okay, is this something I would like to continue in or not? And from what I've seen, no, it usually helps. Even if you didn't continue into it, it kind of, as I mentioned, it kind of expands your horizon into understanding. Okay, I can look at problems at a different perspective.
Okay, thank you, sir. I think we need
Thank
to
you.
wrap up now. It was a really good talking to you, and thanks to the audience which have been listening to us. So, thank you. Bye bye.
Thank you. Bye bye.